July 21, 2024. Everything we know about the red planet forever changed. The drill of NASA's Perseverance rover pierced the rock called Cheyava Falls in Jezero Crater. What it revealed forced NASA to call an emergency meeting of its top scientists. Dark spots on a light background, the so-called leopard spots. On Earth, identical formations are direct traces of ancient microbial activity. Now the exact same patterns sit inside a Martian rock. For decades we searched for life on Mars. Today, the contents of this single rock turn years of speculation into reality. Jezero Crater is a 28-mile-wide scar on Mars. Today it's a sterile, radiation-scorched desert. But 3.5 billion years ago, a massive river smashed through the northern rim, flooding the crater with billions of tons of water, mud, and minerals, turning it into a giant biological reactor. Perseverance is now driving along the ancient riverbed called Neretva Vallis. River deltas are the best natural time capsules on Earth and on Mars. To reach the most promising layers, the rover had to climb treacherous dunes toward an area called Bright Angel. Engineers at JPL held their breath as the rover fought up a steep slope. One slip and the entire multi-billion-dollar mission could have ended. Among thousands of gray fragments, cameras spotted Cheyava Falls, a rock with bright white veins of calcium sulfate, clear proof that water once flowed here. Then Perseverance drilled. When the dust cleared, mission control fell silent. Dozens of dark spots, each just a few millimeters wide, formed a perfect leopard skin pattern. On Earth, this exact pattern forms through redox reactions, microscopic fires, inside rocks fueled by ancient microbes. The microbes burn organic carbon, release energy, and leave dark chemical scars behind. Each spot is like an empty plate after a microbial feast. To test if these spots were biological, Perseverance fired its most powerful instruments. SHERLOC, the ultraviolet laser, scanned the rock and found complex organic molecules concentrated exactly inside the leopard spots. These are the same carbon chains that form the foundation of all life on Earth. Then PIXL, the pixel X-ray scanner, created a chemical map. The outlines of the spots are rich in iron and phosphates, the classic signature left by bacteria on Earth. Place a thin section of this Martian rock next to the oldest terrestrial rocks from Australia's Pilbara Desert under a microscope and you cannot tell them apart. NASA's official statement: "We have never seen such a convincing and complex set of evidence in a single piece of Martian rock." But Mars is the master of illusion. Right next to the organic spots, the rover detected large crystals of olivine, a mineral that only forms in molten volcanic magma above 1,000 degrees Celsius. Any known life would have been instantly incinerated. This creates a massive paradox: biological signatures sitting side by side with volcanic hell. Could the planet itself have forged these patterns through overheated metal-rich groundwater? On Earth, scientists have been fooled by similar mineral formations before. Perseverance can only read chemistry. It cannot see actual cells or cell division. So we have a perfect chemical signature, but we still don't know its author. The rock has already been sealed inside an airtight titanium tube, the most valuable time capsule in human history. The only way to settle this is to bring it back to Earth. That's why the Mars Sample Return mission is now the most important space project of the decade. If these really are traces of ancient Martian life, we're standing at the greatest existential shift in history. Life didn't just happen on one planet in our solar system, it happened on two. That means the universe isn't merely habitable, it's probably teeming with life. And according to panspermia theory, life may have started on Mars first and traveled to Earth inside meteorites. We might be looking at our own distant biological ancestors. Today, this tiny rock is the grand prize in a new space race. While NASA struggles with budgets and aims for mid-2030s return, China has already announced Tianwen-3, planning to bring its own Martian samples back by 2031. Whoever returns first will write their nation into history as the possible discoverers of extraterrestrial life. We are frozen between two possibilities. Either we have found the strongest evidence yet of life beyond Earth, or Mars has played the most sophisticated chemical trick in the solar system. The answer is locked inside one small tube, 140 million miles away, waiting for its journey home.